So now let's take a look and we're going to do an infinite solutions example. And so, for example, let's take 4x1 minus 2x2 minus x3 minus x4 equals 0. And then 3x1 plus x2 minus 2x3 plus 3x4 equals 0. And then 5x1 minus x2 minus 2x3 plus x4 equals 0. All right. Now, once again, we've got four variables, three equations. So either we're going to have no solution or we're going to have an infinite number of solutions for this. All right. Also notice that this system is homogeneous. It's a homogeneous system. That is that matrix times our solution vector is going to equal the 0 vector. All right. And so these are actually very special. They are a little bit different. We're going to talk about them a bit more in depth in a little bit later on. Okay. So now what I want to do is I want to say, okay, well, let's go in here and what we're going to do is we're going to transform our system into an augmented matrix. Okay. And now we're going to use Gaussian elimination in order to solve. So what we'll do first here is I am going to take 1/4 times row 1 or multiply row 1 times 1/4 to get a leading 1. So it's going to give me 1, negative 1/2, negative 1/4, negative 1/4, and then 0. Okay. 3, 1, negative 2, 3, and 0. 5, negative 1, negative 2, 1, 0. Okay. Next up is I'm going to add row 1 to row 2. I'm going to take negative 3 of row 1 and add it to row 2. So that's going to be 3, 1, negative 2, 3, 0. And then negative 3 times 1, negative 1/2, negative 1/4, negative 1/4, and 0. Okay. So this is now 0. This one will be negative 1/2. Minus 3/4 is going to give me, or plus 3/4 is going to give me negative 5/4. Then 3 plus 3/4 is going to give me 15 over 4. And finally 0. So my new matrix is going to be 1, negative 1/2, negative 1/4, negative 1/4, 0, 0, negative 1/2, negative 5/4, 15/4, 0, and then 5, negative 1, negative 2, 1, 0. Next up, what we're going to do is we're going to add row 1 to row 3, and we're in fact going to add negative 5 of row 1 to row 3. All right, so that's going to be 5, negative 1, negative 2, 1, 0. Negative 5 times 1, negative 1/2, negative 1/4, negative 1/4, 0. So this is now 0, and that'll be negative 1 plus 5/2, which is positive 3/2. Negative 2 plus 5/4, which will give me negative 3/4. And then 1 plus 5/4, which will give me 9/4, and 0. So my new matrix is now going to be 1, negative 1/2, negative 1/4, negative 1/4, 0, 0, negative 1/2, negative 5/4, 15/4, 0, then 0, 3/2, negative 3/4, 9/4, and 0. Okay? Okay. So, next up, I'm going to have to get a 1 in the second column, second row. So I will multiply by row 2 by -2. Okay. Actually, before I do that, let's just notice, if you can just notice something, we can definitely do that, that's an option. But just notice that row 1 and row 2, okay, so if you look here, the second row, second column of row 2 and the second column of row 1 are actually the same. So why not just, basically, before we do any multiplication, let's just add row 2 plus row 1, or the addition of row 2 to row 1. Okay, just one of them. -1. What this will give us is we'll now have 0, or excuse me, 1, -1/2, -1/4, -1/4, 0, 0, -1/2, -5/4, 15/4, 0, and we'll be subtracting the two of them, so we'll end up with 1, 0, +4/4, so 1, then -1/4 minus 16/4, so this is going to be -4 and 0. And so that actually kind of cleans things up just a little bit for us. All right, so what we now get is we've got 1, 0, 1, -4, 0, 0, -1/2, -5/4, 15/4, and 0, and then 0, 3/2, -3/4, 9/4, 0. Now that I have that, what I'm going to need to do is I'm actually going to be, I think I'm going to add 3, okay, of row 2 onto row 3. So again, kind of the same idea, right? Why change it into a 1 if you haven't, if that second column's all in terms of halves, why change it? Because you're just going to change it back. So consequently, we'll take this and we'll say, okay, so this is going to be 0, 3/2, -3/4, 15/4, 0. Excuse me, 9/4, 0. 0, -1/2, -5/4, 15/4, 0. Multiply this by 3. This gives me now 0, 0, -18/4. Okay, then we got 45/4 plus 9/4. That's 54/4, 0. So now that gives me 1, 0, 1, -4, 0, 0, 0, -0, -1/2, -5/4, 15/4, 0, 0, 0, -18/4, 54/4, and 0. All right, so now what I want to do is I actually now want to turn this, turn row 2 into a leading 1. So I'm going to take times 2. So I'm going to multiply row 2 by -2. So that now gives me 1, 0, 1, -4, 0, 0, 1, -5, so -10/4, which is, it's actually 5/2. 15/4, so that's -30/4, and so that would be, or it's 15/2, so it would be -15/2. 0, 0, -18/4, 54/4, 0. All right. Now what we'll notice is we have zeros below and above the ones, so that's awesome. That's exactly what we want. And then we have we have a leading 1 here, zeros above and below. So now I can move on to the next column. all right? So I want to get this as, turn this into a 1. This is definitely something I want to do. I'm going to multiply then, I'm going to multiply row 3 by negative 4 over 18, okay? And so what that's going to give me now is going to be 1, 0, 1, negative 4, 0, 0, 1, 5 over 2, negative 15 over 2, 0, and then 0, 0, 1, and then what we'll get is 54 over 18, or actually negative 54 over 18, which is in fact 3, or negative 3, 0. Excellent. Whew. Great. So now what I'm going to do next is I'm going to add, we want to get zeros above and below, so I'm going to add row 3 plus row 1, that's going to be times negative 1. So that's going to give me then 1, 0, 1, negative 4, 0, 0, 0, 1, negative 3, 0. Multiply this one by negative 1, 0, 1, 0, 0, 1. Great. And so my new matrix is going to be 1, 0, 0, 1, 0, 0, 1, 5 halves, 15 over 2, 0, 0, 0, 1, negative 3, 0. Okay? Now, finally, we've got to get a 0 right here. So what we're going to do is I'm going to add row 3 to row 2, and it's in fact by negative 5 over 2. Okay? So that means that what I'm going to get is I've got 0, 1, 5 over 2, negative 15 over 2, 0, 0, so times negative 5 over 2, 0, 0, 1, negative 3, 0, and this actually ends up being 0, 1, or 0, 1, 0, 0, 0. So finally, my finished reduced row echelon form is 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, and 0, 0, 1, negative 3, 0. And that's my completed form. Okay? Now what I want to do is I actually want to transform this back into an equation. And so I can kind of shorthand it. I don't actually need to turn it into a matrix equation first. I can actually rewrite it as a system, knowing that this is my x1 term, this is my x2 term, x3, x4. Okay? So what we have here is x1 plus x4 equals 0. We have x2 equals just 0. And then x3 minus 3 x4 equals 0. Okay? And so what I'm seeing here is if I look, this variable right there, okay, that's free. So x4 is a free variable. So I'm actually going to, and the reason why it's free is because there's no pivot in the x4, right? No pivot for that variable means free. Okay, so x4 is just, we're going to call it s. Okay, we'll call x4 s. So x1 is going to equal negative x4, which means that it's going to equal negative s. x2 will equal 0. x3 will equal 3x4, which equals 3s. And then, of course, x4 equals s. So when I write this, if I write this in terms of s, what I'm going to get is I'm going to get my solution vector, call it x, my solution vector, is going to equal negative 1, 0, 3, 1. Okay? And this is a line of vectors. It's a line going through the origin. It's a line going through the origin, all right? And anything that actually happens to be on this line is a solution to this system. So there's an infinite number of solutions, anything that actually happens to be on that line. This is not a single solution. It is a line of solutions, or a vector of solutions, right? And how we know that is because we have a free variable. Single free variable means that we should expect only one vector as our solution. All right, so we've seen now Gaussian elimination happen one more time. What we've noticed here, and one of the things I want to kind of point out that happened, is that we had this homogeneous equation, meaning that it was all zeros. Now, if you watch, the thing that never happened as I was adding up values and doing my Gaussian elimination is that last column, okay, the solution column never changed. And we're going to see that, in fact, if you're dealing with homogeneous linear equations, that you actually don't even need to deal with the zeros. You can just assume that the zeros are not going to change because they won't. Add anything to zero, you get zero. You get the same number, so add 2 zeros, you get more zeros. Multiply by something by zero, you get zero again. And if we permute two rows that happen to have zeros in them, they're just going to stay zeros. So there's no change that happens to that solution vector over here if we happen to have a homogeneous linear system. Okay, so that's kind of like a handy thing to notice. Another thing to notice, whenever we have a value, right, or excuse me, whenever we have a column that does not have a pivot, that column represents one of our free variables. Okay, we can actually, in fact, write that. I'll write that down here. Whenever a column does not have a pivot, that column is a free variable, or it corresponds to a free variable. All right, so that actually concludes our demonstration for Gaussian elimination at this moment.